Hello again, Chem 2. I wanted to go over the e-learning homeworks so that you could use that to study and help you with the test that I've already posted for you. I told you could wait till I did this in order to do the test, and we've already done the test and have done quite well on that. But the formula that we're using is the natural log of material in at some time later over the original amount equals negative 0.693 over the half-life times the time. In problem number 1, you were told that how many days are required for 3/4 of a given amount of thorium to decay. And so that means then if 3/4 of it's gone, it doesn't matter how much you started with, you get 25% of it left. So just use 1 gram, make life easier for yourself. So you can say the natural log of 0.25, and I'll put that in parentheses, might make it easier for us, times the half-life of 18.72 days, divided by negative 0.693 equals time, which equals 37.44 days. Now you could also look at it in that you started with 1, a half-life later you'd be 1/2, a half-life later you'd be at 1/4, so that's 2 half-lives. 2 times 18.72 is 37.44 days. In the second problem, you were asked to find the given amount of substances left after 26.72 hours. So what's the half-life? So again, using the exact same problem and solving for half-life, or excuse me, the exact same formula, you get t to the 1/2 equals negative 0.693 times the time, and this case here was 26.76 hours. And then you divide that by 0.0625, which is how much that's left, and the half-life becomes 6.69 hours. Or again, you can look at 0.0625 as 1/16. So a half-life would be 1/8, a half-life 1/4, a half-life 1/2, and a half-life 1. So 4 half-lives. It took 26.76 hours to get to that, so 26.76 divided by 4 is 6.69 hours, the exact same answer. Number 3, I was hoping that would be very easy for you. You got helium, which is obviously written like that, and you're reacting that with beryllium. I say reacting, but keep in mind it's a nuclear reaction. And so 2 plus 4 is 6. What element corresponds to atomic number of 6? Of course, is carbon. And 4 plus 9 is 13. That's all you had to do for that particular problem. Okay, all you had to do. On problem number 4, you need E equals mc squared. And this particular problem, you're told you have this much energy. And what you're asked to find, what is the rate at which mass is lost from the sun? Okay, so in other words, you're trying to solve for mass. So E divided by c squared equals mass. And so you have 3.9 times 10 to the 23rd joules. And the speed of light is 3.00 times 10 to the 8th. And that has to be squared, and you get meters squared, seconds squared. And then I told you that the unit for the joule, I told you that someplace, I don't have it on this particular worksheet, I think the one I gave you did. But anyhow, a joule is also a kilogram meter squared per second squared. And then we're told that this much is ejected into space every second. So we actually have another second down here. You do the math of this, all the units cancel out, and you end up with kilograms, and you get 4.33 times 10 to the 6th kilograms per second. So a significant amount of mass goes into the atmosphere every second. I'm going to try to work in problem 5 so I don't have to erase all of this. And problem 5, It says you find a fossil is 35% carbon. Compared to the living sample, how old is the fossil? Well, again, you're using this formula, and so you're solving for time. And you see that time would equal the natural log. You said you get 35% left, so 0.35 times the half-life is 5,700 and what I gave you there, 730 years. And of course, then that is divided by negative 0.693, and then time equals 8,680 years old. So that's how you do the first 5 problems on the worksheet. On the second one, I can just hold mine up for you to see. I'll bring it into focus. That's the way I did it. It really doesn't matter. I saw all of them. You did this. You have to label each one, as you can see I've done. And in the first one, bring it in closer, there's 8 alpha and 6 beta. And notice I did not go below lead. You cannot go below lead when you're doing this because lead's stable. Most isotopes of lead are stable. You get below lead, those are all stable. So that's why you can't go below lead. And on the second one, again, that's the way I did it with alpha and beta. And alpha in this one was 7, and beta, there are 4. So hopefully most everyone did that right. The only mistakes I saw was a couple of you went below lead. A couple of you got a little messed up in the math. Remember, an alpha is a helium nucleus, and a beta is simply an electron. And so your atomic number increases by 1. And then, so besides the math error, not labeling, and a couple of you did go below lead. So that's the only mistakes I saw. So otherwise, very good. Hope this helps you review for and take your exam. Thanks. Bye.